In the last video, we were exploring compatible and incompatible changes to a serializable class. Incompatible changes to a class means you're going to break the reconstitution process for previously serialized data. There are use cases where this is the desired behavior, but there are other circumstances like the game player's session data I've set up in the last video. In this video, I've got the data streams project open. There are two methods I mentioned on previous slides called readObject and writeObject that are hooks into customizations. These aren't methods we override though. If we implement them on our serializable class, much like the serializable UID, the serialization process will use our explicit versions. We have to stick to the signatures of these methods as they're identified in the serialization documentation. I'll start by demonstrating the readObject method, creating this on my serializable player class. This is a special method whose signature doesn't change. At the time of this video, I'm not aware of any generation tools in IntelliJ to help us with these methods, so I'll just type this out. When you do create this method, you'll often want to call the default serialization process first. That's done by invoking the default readObject method on the stream argument. One thing we can do is make changes to the object that got deserialized. So here, I'm going to make some compensation for losing the player's top score by defaulting all players caught in this situation to a default score of 1 billion. Before I run this code, let's see what IntelliJ's warning is for this method. I'll hover over that and I can see IntelliJ is suggesting I annotate this method, so I'll select that. This annotation informs all interested parties that this method will be used by the serialization process. Okay, I'll run this now. You can see the reconstituted player has a score of 1 billion. This might be one way of dealing with any players caught in this upgrade problem. Before I talk about more options, I next want to talk to you about the transient modifier. I mentioned it on the slides about compatible and incompatible changes, but I haven't really said what this modifier is. The transient modifier is used to indicate that a field should not be serialized. This can be useful for variables that contain sensitive information or just variables that don't need to be persisted for other reasons. Let's say I've got an account ID for my players to manage billing and so on. I'll include this as a private final field on my player and I'll add the transient modifier here as well. I'll include this field in my constructor as the first parameter. I'll also assign the field to that method argument. Next, I'll add it to my toString method. I've got an error in my main method where I'm constructing the first player instance. I need to include an account ID in this constructor, so I'll pass 555 as the account ID in the first argument. I'll run this code. Notice that I didn't get any errors, citing a transient field doesn't cause any incompatibility between versions. This wasn't a great test though of the transient modifier because my tim.dat file never had the account ID in it at all. I'll serialize a second player with this new class structure and then immediately deserialize that player. I'll call this player Joe, account ID 556, name Joe, top score is 75 because he's only played once. His weapons can be a crossbow, a rifle and a pistol. I'll serialize his data to a joe.dat file. I'll write the Joe object to that file. I'll immediately deserialize the Joe instance, assigning that to the reconstituted Joe variable. I'll print the original object. Finally, I'll print the deserialized object. Running this code, you can still see the ID is 0 for Joe because the account ID wasn't written out for this player, and that's because I declared it transient. Now, let's see if we can leverage Java serialization, but wrap some of our version control around parts of it. First, I'm going to create a new private static field on this class and call it version. Like the readObject method, I can get a hook into how Java writes data with the writeObject method. After the readObject method, I'll add the code for this next method. This method is private void named writeObject and has one parameter, an object output stream. And it throws an IO exception. I'll print something to the console so that I know when this code is executed. I'm going to write out my static version number. Normally a static field wouldn't get serialized, but since I'm customizing this code, I can do whatever I want. I'm going to store my own version number here. I can write the fields in any order I want, so I'll write the collected weapons first, then the name. Lastly, I'll write out the top score as an int. Again, IntelliJ gives me a warning on this method, so I'll select to annotate that. Now, I need to redo the readObject method. When you write a customized writeObject method, as I just did, you can't simply delegate to the default readObject method, which is what I'm doing right now in this method. If I don't change this method, my writes will be out of sync with my reads and the code will fail. I'll comment out the two statements that are there. I want to read everything in, mirroring the way I wrote it out. I'll use readInt to get the version. I'll set this to a local variable. I'll do the other reads, so the object first to get the list of weapons, and I need to cast that to a list of string. I'll get the player name with readUTF. Then I'll get the top score using readInt. IntelliJ is broadcasting a warning about this cast, but since I know this really is a list of string, and this is what I want, I can add another annotation to suppress this warning. The annotation is suppress warnings, and I can pass that the string literal unchecked. I'll cover annotations a bit later, but this will get rid of that warning. I'll change my constructor so that top score is once again an int. I'll set top score inside the constructor, changing this .big score to this .top score. I want to print top score out in my toString method, so again I'll change big score to top score here. Next, getting back to my main method, I'll uncomment the line that writes out the first Tim object. I'll run this. I can see my customized writing method was called during the two deserialization processes. I can also see they both have their top scores reconstituted correctly. Now notice what happens if I make top score transient. I'll scroll up to the player class and add the transient keyword after the private access modifier before the int type. I'll run my code again. Even though top score is transient, it didn't matter because my methods and my rules now override Java's rules. I'll remove the transient modifier and now I'm going to make this a long. I'll also update my static version number for this change to a 2. Next, I'll change my writeObject code to write a long, not an int, when it's writing out the top score. Before I rerun the code, I'll make sure to comment out the first writeObject method call again in my main method, the one that writes out Tim. I wanted to keep the version that was written when my top score was declared an int. And again, I'll run this. It runs successfully, even though I changed my field from an int to a long. My serial UID didn't change, it's always been 1. Because I'm reading and writing using my custom code, I didn't get an exception reading the data in. But there's a problem. Joe's score is 0. The reason it's 0 is because we're reading his score in as an int, which worked fine for Tim, whose code was version 1. But it's not so great for version 2 because the score's data is stored in 8 bytes. When I read the first 4, using readInt, I just get zeros. I need to change my read method, but I don't want to change it for version 1. This is where my version number comes in handy. I can change my readObject code to do something different based on the version I read in from the serialized object. I can fix this problem with a ternary operator testing the value of the local variable serialized var. If it's 1, I'll read an int. If it's 2, I'll read a long. I'll run this again. Happily, at last, my code works for both versions of the serialized data. This was a lot more work certainly and required me to implement tracking my own version number. Why didn't I just change the serial version UID? Let's do that. I'll change it to 2L. Running my code. I get the exception with the message local class incompatible because the serial version UIDs are out of sync. I'll revert that last change. Now, there are use cases where you might want to invalidate all stored session data like this. But if you hope to recover the data in the event of changes, writing your own readObject and writeObject methods is one option, although it doesn't prevent all invalid class exceptions. In fact, the only reason this example worked was because on the version 1 class of player, the top score field was originally transient. If I had not serialized the Tim instance with the top score field transient, this code would have failed. Even though I'm manually writing this field out, Java's serialization checks still get exercised before the process runs, and this change, without the transient modifier, would still be an incompatible change. The serialization would have failed. Serialization, out of the box, is a powerful tool, but I hope this exercise showed you some of its complexity and how important it is to use it in a planned and more thought out fashion. We've covered a lot of ground in this section, and this video ends this section on Java's I/O, so congratulations on completing another section. In the next section, I'll be starting a brand new topic talking about concurrency and threads, so I'll see you in the next video.